Hey everybody, Mr. Covey here, and today we're going to be talking about graphing logarithms. Okay, so you should have a notepad that looks like this, and I want you to follow along here. Graphing logarithms is a little bit tricky. We're going to rely heavily on our calculator for sure, but I do want to show you that you can do this without a calculator. Okay, the thing that's hard about it is when you graph something that you don't know what it looks like, you make a table. All right, so we're going to make a table. The problem is our normal strategy of like, I don't know, I'll just put -1, 0, 1, 2, that doesn't work. And the reason that doesn't work is because if you look at our log here, and you think about putting in x values, let's say you put in 3, and you think about log base 2 of 3. Okay, well that's asking the question, 2 to what power is 3? I don't know what this is. So I can't plug in 3. Like, it's not something I can plug in. So instead of just plugging in random numbers, you have to be very thoughtful about what you put in for x. You have to think about, hey, if I'm looking at log base 2 of something, what do I want to put in for x so that I'm actually able to answer that question using just my brain? First thing that comes to mind is put in 2 for x. Excuse me. What's log base 2 of 2? 2 to what power is 2? 2 to the first power is 2. If I think of something else to put in for x, I think about 1. Log base 2 of 1, 2 to what power is 1? 2 to the 0 power is 1. How about 4? 2 to what power is 4? 2 to the second power is 4. How about a half? 2 to what power is a half? 2 to the negative first power is a half. And I get some points, and I'm going to plot those points real quick. And I'm going to get a graph that looks like this. This log graph looks like this. And there's a couple important features I want you to notice. If you remember, exponential graphs have horizontal asymptotes. So log graphs always have vertical asymptotes. I'd write that down in big letters. Log graphs have vertical asymptotes. Oops, sorry. In this case, my vertical asymptote's at 0, and it's x equals 0. Vertical lines are x equals. And if you think about domain and range, if you look up and down, this graph goes all the way down to negative infinity, goes all the way up to infinity. If you remember well, I'll say that in a second. The domain, the furthest left it goes is 0, and the furthest right is infinity, and it doesn't touch 0, so I'm going to put a parenthesis there. If you remember for exponentials, the domain was all real numbers, and the range was restricted. This is flip-flopped, and that makes sense because if you remember, logs and exponentials are inverses. They're flip-flopped. Okay, so it makes sense that the domain and range are flip-flopped. Same with the asymptote. Instead of being horizontal, now it's vertical. Okay, and so that connection between logs and exponentials being inverse operations is going to become really important. They undo each other. They're opposites. We are not going to usually log or graph these logs by hand. Instead, we're going to use your calculator. And I'm going to show you how to do that here. Grab your calculator. And for most of you guys, typing this in your calculator is going to be really easy, okay? I have an old calculator, so it's a little more difficult. But if I want to type log base 3 of x in, for most of you guys, you're going to hit the math button. Or sorry, excuse me, go back. Erase it. You hit y equals. You're going to want to type the function in there. In order to do a log with a base, you're going to hit the math button, and you're going to go down to log base. Should be down here somewhere, way down. And you're going to use log base. My calculator is a little different. So I'm going to type it in a little bit weird. Do not type it in like I have to type it in unless your calculator doesn't have log base. So I'm trying to type in that right there, and I type it in a weird way. Okay? Regardless, it gives me the same graph. I'm going to hit graph. This doesn't exactly look like the other graph because look, kind of just like it's like all pixely and it cuts off there. That's when we should not be using the graph to help us. We should be using the table. A few things to notice about the table. First off, we have a bunch of errors here, and that's because the graph doesn't go over there. Those aren't in our domain. Our graph stops right here. The other thing you should notice is a lot of them are decimals, and that's the thing we talked about earlier. Like only some of these x values actually give you out y values that you know. So it might be helpful to plot those easy points like 9, 2, 3, 1, and 1, 0. So let's plot those. 1, 0, 3, 1, and then 9. Now you need to know the overall shape, because if you just graph this, that's wrong. That's not the log graph. The log graph has a vertical asymptote at x equals 0, and so it comes down here like that. You need to draw that vertical asymptote in as a dotted line. Okay. Log graphs have vertical asymptotes, and so far they've all had their vertical asymptotes at x equals 0. This is just like log base 2 above. The range is all real numbers, negative infinity to infinity, and the domain is 0 to infinity. Okay. Flipping to the next page. This is a little tricky. So this is log base 2 of x plus 1. The way I would think about this is we're going to use our calculators, but it'll really help if you remember a plus 1 on the outside. How does it move it again? Moves it up 1. So this is still going to look like this. It's still going to look like a log graph, only it's going to be shifted up 1. So if you keep that in mind, this won't be too bad. Type in your calculator. Again, I have to type mine in weird. My calculator's old. It's a first world problem. Old calculators. But you should be able to use that log base button. Okay? If not, you can type it in like I'm typing it in here, and it will work. Again, I'll let the graph just to look at it. That's not going to be very helpful. I'm going to go to the table. Table's where it's at. I'm going to grab the easy points. All right. 1, 1, 2, 2, 4, 3. 1, 1, 2, 2, 4, 3. I connect them, but I'm going to remember that I have a vertical asymptote. I know what you're thinking. Hey, didn't that plus 1 change the vertical asymptote? Here's my vertical asymptote. Moving the graph up 1 doesn't change that. Look, I move the graph up 1. It still has the same vertical asymptote. So moving it up 1 did not change that vertical asymptote. My asymptote is still at 0. Oops, sorry. Still at x equals 0. My range is still all real numbers, and my domain is still 0 infinity. You may notice that the asymptote is always where the domain starts. Okay? And one last one. Again, if we think about the transformations, this will be helpful. A -2 on the inside should be like, oh wait, -2 on the inside, that's horizontal, it's also backwards. A -2 on the inside moves it right 2. So now I'm going to have my normal log graph. Only it's going to move right 2. So I'm going to move it right 2. Notice that when you move the graph right 2, the asymptote's going to be right 2 as well. And we'll see that in the table, but just think about this kind of a picture. Type it in again. I have to type this in a little weird. I have to type log of x minus 2 divided by log of 3. Okay. Again, yours should be easier to type in if you have a newer calculator. Otherwise, it's kind of annoying. And I can talk to you more about it in class if you have an old school calculator like mine. Okay, I'm going to hit it. You notice it is shifted right 2. But again, it's giving us an incomplete picture because our calculators are too old school. So go to the table, grab some nice points. 3, 1, 5, 2, 11, 3. 3, 1, 5, 2, 11, 3. And again, I have to kind of know that it moved right 2, so I know to put the asymptote at x equals 2. So my graph looks like this, and it should be smooth. My hands are just shaky. That happens when you get old. Again, the real way to get the asymptote is to think about the transformations. I'll give you another little hint. Probably shouldn't say this, but look, the table. If you look at the x values, where do the x values start getting messed up? At 2. That's another clue that 2 is what messes it up. 3 is fine, 4 is fine, 5 is fine, 2 is messed up. And that's because 2, x equals 2, is where our asymptote is. Our range is all real numbers. Our domain, how far left do we go? 2. How far right? All the way to infinity. Okay. On Friday in class, we'll be practicing graphing logarithms. So if you could come in with these notes done, kind of be ready to practice that some. We're really going to focus on our calculator, but bringing that outside transformation knowledge in helps a lot. And that concludes this graphing video. There is another video on finding inverses, which I would like you to watch as well. Thanks.